time now, 1:10 p.m. Central Time, 2:10 Eastern, 18:10 UTC for those joining around the world. If you're just now hopping into the live coverage here, welcome. You're watching Spaceflight Now's dedicated live coverage of the flyby of Artemis 2, making its closest approach to the lunar surface that it will conduct on the Artemis 2 mission, a period of lunar observation for which the crew has been training for years, going through various trainings in the realm of geography, of lunar science, understanding the regolith and various geological terms, understanding the types of details that they may see as they're looking down on the surface of the moon, and also making observations about how they're experiencing this whole affair as the first humans to enter into what is known as the lunar sphere of influence since the Apollo 17 astronauts left in 1972. As the crew is approaching the closest they will be to the near side of the moon, they have, of course, surpassed the distance record set by the Apollo 13 astronauts. That official time of passing that record was 1:56 p.m. Eastern, 17:56 UTC. During Apollo 13, that crew traveled 248,655 miles from Earth. The distance record will continue to be broken, and we'll get official final numbers once they do make that furthest point passing by. As you can see, the moon is growing larger for the cameras that are on the outside of Orion, and of course for the crew inside the spacecraft. For a sense of what this is like for the Artemis 2 astronauts that are preparing to make the important lunar observations here in the hours to come, if you imagine holding a standard basketball in the palm of your hand and then extend your arm to its furthest point away from your body, that's about what the moon will look like for the Artemis 2 crew. The crew is set to make their closest approach to the lunar surface, which is about on the order of 4,000 statute miles. That's set to happen at about 7:02 p.m. Eastern, 23:02 UTC for those joining around the world. Speaking of joining around the world, we want to thank the more than 7,100 of you who are watching along with us live today. We certainly appreciate your time and attention. It's been quite an honor and a privilege to be covering this piece of history for you all. Certainly a team effort to make this coverage happen, and we appreciate your being here with us as a part of documenting history. The opening of the show was a bit busy, so just to get the table setters out of the way, if you haven't already, you could do us a big favor just by clicking the like button here and sharing this stream. That will allow some more folks to find their way to this live lunar flyby coverage. We also want to extend a big thank you to our team back in Florida who's supporting us on a technological frontier to make this live stream possible. So big thanks to our Spaceflight Now editor, Stephen Young, alongside our extraordinary photographers, Adam Bernstein and John Pisani, hopping in various capabilities to make sure that we've got good, robust coverage for you today. As we did earlier in the show, we will do our level best to not step on the Orion to Earth communications. We, along with you, dear viewer, want to make sure that we are hearing what's being communicated to the crew as well as everything else that is happening with this mission in the flyby. We'll be bouncing back and forth as the views look the most interesting between the real onboard cameras on the Orion spacecraft as well as within the Orion vehicle, and computer representations of the flyby, as you can see with this visualization that was created by NASA to give you a crisper view that gives you a little bit of a third-person perspective of the orientation of Orion, both the European service module, which you can see that's the part with the main large engine nozzle, as well as the supporting smaller engines. That is the cylindrical piece of Orion, and then there's the stage adapter in between the service module and the crew module up top, and you can just barely make out a little bit of the top of the crew module here in the visualization if you look near from this orientation, what I'll just call the bottom of the full Orion spacecraft from this perspective. Back here in Mission Control Center, Houston, this is the White Flight Control Room, or the White FICR, where we're looking at the Capcoms for today. This is the station that primarily is in charge with communicating with the crew members on board the Orion spacecraft. Now, the team goes through a rotation series with all of the positions in the control room here. That's in order to make sure that everybody who is on console is fully rested and ready to support all the various needs and impacts to the mission in all the various capabilities. If you look in the right side of the screen, actually before we pivot away from the position where we're currently in here, of course, we're on Monday, April 6th. The two Capcoms that are currently in that position, they're not always going to be astronauts, but in this case, they happen to be for this particular, what are called orbits. You could think of them as first, second, and third shift, but for orbit number 1 today, we have on the left-hand side in the blue shirt and the red tie, that is NASA astronaut Stan Love. And to his left, our right, in the charcoal gray jacket, that is Canadian Space Agency astronaut Jenny Gibbons. Gibbons trained to be one of the two backup astronauts for the Artemis II mission, alongside NASA astronaut Andre Douglas. As the day goes on and we see a crew shift here in the White FICR, again, we're currently in what is referred to as Orbit 1, taking over in Orbit 2, which will be sort of the middle of the day for the Artemis II crew from their perspective. We'll see Tess Caswell take over, who is the lead Capcom for the Artemis II mission, alongside the aforementioned Andre Douglas. To the right, the gentleman in the, some people may quibble with my color description, I'm going to call that maroon shirt. Taking a bite of lunch as we're currently at 1:19 p.m. here Central Time. If I wasn't on the mic, I'd be doing the same, taking a bite of a cold wrap that is sitting in the fridge beside me. Hopefully I'll take a moment to steal away and grab a little lunch myself. But that is Jeff Radigan, one of the flight directors who is supporting the Artemis II mission. Just as a table setter for what we are expecting schedule-wise with today's flyby operations, of course, it's 1:20 p.m. Central Time here in Houston, Texas, 2:20 p.m. Eastern for all of our friends back in Florida, as well as along the East Coast and in just the broader Eastern Time Zone, 18:20 UTC for the rest of our viewers around the world. All these times I'm going to mention are in Eastern time for the sake of brevity and for everyone's understanding. Coming up in about 25 minutes time at roughly 2:45 p.m. Eastern, that's when the official lunar observation period, shorthand the flyby, that will take place beginning about quarter till the top of the hour. As we heard from the Artemis 2 lead science position that is currently here in the science seat in the white Ficker. That is Dr. Kelsey Young. She reminded the crew that it will take time for their eyes to adjust, as we will hopefully get some camera views back in Orion at some point in the not too distant future. They will be dimming the lights in the crew cabin there in order to make sure they've got the best optical viewing for the cameras. As our photographers Adam, John, and Michael can attest, the worst thing you want to have happen in a situation like this when you're shooting out of a window is to have any kind of glare. So the crew have been training in order to shoot through the windows of the Orion spacecraft. One of their notable training sessions happened back when they were here at the Johnson Space Center in a facility called Building 9, where they have a number of big mock-ups for various astronaut training exercises. And next to what is called the medium fidelity version of the Orion spacecraft.
Houston, integrity for camera serial numbers.
Ready to copy.
Hey Jenny, these are card numbers for the various positions. For the long lens on the D5, we will have individual cards. Victor's 1008, Jeremy 1019, Reed 1012, myself 1015. For the Z9, we will have one card that is dedicated for today, serial number 1007. For the cabin camera D5, we will have one dedicated card for today, serial number 1022.
All right, Christina, we copy all. Thank you.
We just realized that we have Earth out window 1 and Moon out window 2. And Earth out window 4 and Moon out window 3. And it gives you the best idea of scale we have had yet. The Moon is about 3 to 4 times the size of the Earth, and it is almost full, and the Earth is just a small crescent out there. It's magnificent. I got a picture of it with the wide lens. Such a majestic view out here.
Amaze, amaze, amaze. Thank you, Reed.
And as you've been hearing from Commander Reed Wiseman, capturing that majestic view, and you can just imagine all the wonderful photos that will be shared throughout the course of tonight and into the day tomorrow, as all the high-resolution images, or a good chunk of them, are downlinked and able to be shared with the public. Some of the other communications you were just hearing between the Capcom on duty, Jenny Gibbons, and Christina Cook, mission specialist on board the Orion spacecraft, reading off the various serial numbers for the SD cards. Again, as the photography community can attest, one of the worst bits of happenstance is when you're quickly working through a project and you're bouncing around different cards and things get put in one place or another and you forget whose is who and you have to plug it into a computer to figure out. They're trying to mitigate all of that by making sure there's a clear understanding of who's managing which SD card into what camera that's going, so that when they downlink these images and are able to start processing them, they, on board Orion, know whose is who, and then down on the ground they can identify which crew member shot what photo. So you'll hear lots of little detaily things like that as we go throughout the coverage today, as the crews are making sure they're being thorough in their lunar observations and thorough in their media management. We're less than 20 minutes away from the point of the lunar observation starting. I want to thank a couple folks in our live chat for your support of our flyby coverage today. Thanks to Jane Rankin for the £2 super chat, who says, "So excited. Thanks, Will, for all you do." Well, thank you for the kind words. I will extend that out to the Spaceflight Now team. This is very much not a solo venture making this all happen. Want to welcome in new channel member JMD Manch, or Manche. Apologies, JD, or JMD, if I mispronounced your last name there, but thank you for joining at the pad leader level and then upgrading to mission specialists. We certainly appreciate all of you who are able to support us at the higher level. That allows us to keep our entry level for membership at the current level it's at. Also, thanks to Nacho Broyan for gifting 10 Spaceflight Now memberships. We really appreciate that generosity. And to all of our newest gifted channel members, welcome aboard. We're glad to have you with us. If you haven't already, be sure to thank Nacho in
Houston Integrity for Attitude.
Go ahead.
Hey, Jenny. Understanding we are in final attitude now for the lunar flyby, would it be possible to pitch the vehicle down 5 degrees? That would allow us to get the D5 long lens flush and have the least amount of window distortion.
We're checking.
Copy.
mission elapsed time for the Artemis 2 mission, currently 4 days, 19 hours, 54 minutes, 47 seconds, and counting up. Very cool super chat coming in that I'm seeing here. Cynthia Nielsen with the $5 super chat. Thank you, Cynthia. Saying, "So awesome. My uncle designed the camera that first went to the moon. He is seeing this today. Go Artemis 2. Well, that is extremely cool, and please give your uncle our warmest wishes. And
Houston Integrity for timeline.
Go ahead.
Jenny, just to make absolutely sure that we start observations when expected, we are showing in Optimus that observation time starts in about 15 minutes, and in LTP that our first target, discussion 1, starts in about 29 minutes. Can you confirm you'd like us to start discussion 1 in 29 minutes at 1900 GMT?
Christina, we are tracking that discussion 1 should start at 18:45. That's 15 minutes from now.
Okay, copy all. It may be a granularity issue with LTP, but understand that we start that observation in 15 minutes, and I bet when we get there, the green line in LTP will match the start of the white band for discussion 1. I think it's just a matter of the labeling and the granularity. Thanks for confirming.
Copy, and we'll look into that a little bit more on our side as well.
The communications that we were just hearing from...
Christina, can you verify for us that your green line is moving on the timeline page of your LTP?
Affirm. Jenny, I do think we're good. Looking closer, I see the labels are just not aligned with start or end times of the white visible bands. It fully makes sense now, so I think we are all set. We'll look forward to starting some observations in about 13 minutes.
Copy. Thanks, Christina.
Couple things to pull out of those last words we were hearing from Christina and Jenny. Jenny Gibbons, the Capcom on the ground here in the White Flight Control Room, and the, of course, Christina Cook, one of the mission specialists on board Orion. The LTP that was referenced a number of times, that is the Lunar Targeting Plan. There are a series of 30 points of observation that the science team have picked out and curated and given to the Artemis II crew that they want them to most specifically hone in and target as they make their way through this multi-hour period of lunar observation. The comments that you heard regarding the first discussion, which is coming up here in a little bit at 1845 UTC. That is a series of... It starts the point of science observation and focus, and helps both the team on the ground and the team on the Orion spacecraft have a roadmap, if you will, of where they will be honing in on. So the first discussion, as they're calling it, is a general welcome, bringing the focus of this part of the mission really into clear understanding for everybody. Just kind of a table setter, if you will, for the start of the observations. Then they'll make a discussion point about the near side versus the far side.
Houston integrity, if we roll left, port 5 degrees, that would get the moon closer to the left side of window 2.
Copy, Victor. We'd like to know if it's pitch and roll or one or the other.
Jenny, we actually thought you already put the pitch in. Had the pitch been put in already?
No, we need a little while longer to talk about it.
For those unfamiliar with the type of terminology.
So, Jenny, I guess what's happening is just as our orbit's changing, where it is in the window is changing, so maybe these fancy little adjustments aren't worth it. It's going to continue to move in the window. Or is the spacecraft going to keep the moon at the same point of the window if we adjust the attitude? I assume the previous.
Right now, we are pointing the center of the window to the center of the moon with 2 degrees of deadband.
Again, we're pausing to make sure we're not stepping on those Earth to Orion comments between Capcom, Jenny Gibbons, and whoever's speaking from the Orion spacecraft. Just a quick note on the verbiage. We're hearing the pitch and the roll. The pitch is the upward and downward movement of, in this case, the Orion spacecraft. And the roll refers to the tilting side to side. That happens along the longitudinal axis, or in this case for the Orion spacecraft, from the top of the crew module down to the nozzle of the main engine. The crew has done a series of manual piloting demonstrations. First one with test pilot, NASA astronaut, and Artemis II mission pilot Victor Glover. That was in the short aftermath following separation from the Space Launch System rocket's upper stage, called the interim cryogenic propulsion stage. And they did a series of maneuvers, both looking back straight down the ICPS after making a 180-degree flip. And then the spacecraft maneuvered to the side of the ICPS and did some more positioning demonstrations, moving along the 6 degrees of freedom. That includes pitch, roll, and yaw. As well as moving forward and backward, side to side, and up and down. The official start of the observation period is coming up in the next 5 minutes. Just wanted to go back and close the loop on one of the super chats I read a second ago from Cynthia Nielsen, saying that her uncle designed the camera that first went to the moon, which is extremely cool. assuming that is the Hasselblad 500 EL camera that flew on Apollo 11. And you'll have to let me know in the live chat if I'm correct about that, or if you're referring to one of the cameras that was used during the Apollo 8 lunar flyby, or Apollo 8 mission, which went into lunar orbit. So we're waiting for the lunar observations to begin and those callouts to start coming down. Thanks to Mike Schmidt for the €2 super chat and then a €3 super chat. Thank you, Mike. Our thanks as well to Melanie Watts for a $10 super chat, who says the Wascom, Texas 5th grade science class wishes you a safe and happy Taco Monday and a good trip. Or safe trip, happy Taco Monday. Yes, love the combination. And now you're making me even hungrier. So appreciate the support today. And a big hello to all you 5th graders at Wascom Elementary. Thanks for watching, and we hope you learn a thing or two about exploring the moon. And hopefully this will inspire some of you to go out and chase your dreams, and perhaps have the privilege of talking to a future NASA astronaut. You never know what'll come down the road for you. Also want to welcome in, or thank Ken Urbanek, one of our channel members, for being with us now at the pad leader level for a full year. Saying thanks, Spaceflight Now, and our moderators. Thanks to channel member Rolly Nevels for the $2 super chat. Says, hey, Will and Spaceflight Now. Thank you so much. Thank you, Rolly. Another channel member, MedTech, with the $20 super chat. Very kind of you, Med. Who's sending virtual Kalashkis for the Spaceflight Now team. Says thanks for the great coverage. Last comment for now, saying this is from channel member I'm Lita, the $5 super chat. Thank you, Lita. Good to see you. Saying another historical moment with the Spaceflight Now family, Will, team, and the mods. And yes, it is an honor and a privilege to be covering this moment in human spaceflight history with all of you. And thanks for stopping by for at least part of it in your Monday mid-afternoon for us here in the United States, and for all of you around the world checking in on this historical milestone.
Houston Integrity We have two folks at the window deep in discussion talking about all of the awesome features that they're seeing. We just had a huge moment realizing that Hertzsprung is about the same size as our incredible Oriental. We're really excited about this target that's kind of new to us. We're orienting on things like how we talk about albedo, finding some of the prevalent things that we're used to from all of our training, and just overall taking in this view. We also are noticing that the moon is still getting noticeably bigger as we go, even when you're watching it continuously. It's great to see these two guys get warmed up.
We love the report, Christina. Thanks. And you nailed it on why we added Hertzsprung. As you'll see in the prompts, we're looking for comparisons to the comparatively much older Hertzsprung compared to the younger Oriental. Great words.
Mission elapsed time on the Artemis 2 flight, 4 days, 20 hours, 12 minutes, 57 seconds. The Oriental basin that was just referenced, described as the youngest large basin on the moon with a dark impact melt interior, bright rings, and a prominent ejecta with secondary crater chains. As we're looking at the moon from the camera perspective here on Orion, the Oriental basin, if you see the right before where the shadow region of the moon is.
One report from the crew at the windows. We can actually see the moon and Earth at the same time right now. It's interesting because the Earth looks way brighter, so the Earth itself seems to have a much higher albedo than the moon. We think this is independent of our eyes focusing because, of course, the Earth is much smaller than the moon in our view, so you could think that your eyes focus for the darker sky, and that means that it only has apparent brightness more than the moon, but since we're seeing both in the same view, we do think that this can be inferred as the Earth as a whole has a higher albedo.
Great observation, Christina, and reminder that as you're starting to look for those subtle color and albedo variations on the moon, the relatively bright albedo Earth might make those a little bit difficult, but as your eyes continue to adjust, we expect you to start to see more nuance on the moon. Thanks.
Great call. Thanks for the reminder.
Of course, the NASA astronauts and the Canadian Space Agency astronaut on board Orion are conducting lunar science right now, and so you'll hear a lot of terms that don't get thrown about in casual conversation, like albedo, spelled A-L-B as in ball, E-D as in dog, O. The way that NASA describes the term albedo is, quote, a measure of the percentage of sunlight that a surface reflects away. So if you think about, as they describe in this Example, fresh snow having an albedo of about 0.85, or in other words, reflecting about 85% of the sunlight that hits it. You may think back to a time where you've been out in the snow, whether skiing or snowboarding or just inundated with snowfall around your neck of the woods. You think about how bright it is outside when you look down at the snow because it reflects a lot of the sunlight back up at you. Conversely, the other example that NASA gives is the open ocean having an albedo of less than 0.1, meaning that it is absorbing more than 90% of the incoming sunlight and reflecting less than 10% of that back at you. So when you heard Christina describing the albedo of the Earth, that means that the light reflecting off of the Earth that is facing the Orion astronauts right now is considerably more so than the albedo of the moon. All of these observations are going to be closely studied and discussed by the principal science team here on the Artemis 2 mission, as well as researchers around the globe as we work to learn more about our own satellite, the moon. One of the reasons why it's important for researchers to learn more about the moon and why it's such a point of scientific fascination, as well as, of course, the beauty and cultural significance that the moon has for cultures and regions of the globe, is that the moon is essentially a geological record of our place in the universe, the various impacts and things that have been experienced in our region of the solar system and the Milky Way galaxy. Things that the Earth largely encounters are things that the moon encounters as well. The difference is we have a lot more, of course, we have vegetation, we have our oceans, we have human activity, and our atmosphere, all of which plays a role in shifting how our Earth has changed over millions of years. The moon, however, is a more pristine record keeper of some of these various impacts and what has come through the cosmos and entered into our celestial neighborhood. And so with things like lunar sample return and with the observation that the Artemis 2 astronauts will be making with their eyes, they'll be able to, as expected, pick out certain colors on the lunar surface.
Science from integrity. We have a sit rep. The targets that are being discussed right now, it's the far side, near side comparison, and hearing some great discussion of browns and greens in the Aristarchus Plateau and how those disappear as you go toward the North Pole, and then over to the far side, you lose the color. You've got Jeremy in window 2, Reed in window 1, having a great discussion. Reed is in window 3. Christina's under window 1, documenting the discussion. And we've got the lights completely off in the cabin. There are some LEDs that we cannot put out that do provide some light scatter. But we have all of the internal lights off. And are letting our eyes adjust as best we can. The window 4 view, you only get about a third of the moon. Tycho is going to go over the horizon soon, and you can see Aristarchus, and then you start to lose the view as you go to the west in Oceanus and Procellarum. So far, the team is on the plan, and the long lens is being put to good use, and recordings are being made, and internal documentation of the configuration and the observations is ongoing. Science, do you have any questions for us at this time?
Integrity Science. Victor, very glad that you provided the first formal science sitrep, as these were indeed your idea. One follow-up question, any relationship between those browns and greens you described? Do you see them blending into one another, and do you see any topography associated with either color?
I don't want to bother the window team. I just heard that, overheard that, and so I'm sorry I don't have that detail yet. I will eavesdrop and see if I can pick that up. I will try to answer that at some point. I also heard a comparison of the albedo in Aristarchus, that crater, the very high albedo spot. You can see it on the near side. There is a feature called, I believe, Burgess alpha, that is equally or maybe higher albedo. I apologize for the gaps. I'm trying to listen and talk at the same time, but I will try to get some more information to correlate those colors from Aristarchus for you.
Understood, Victor, and good call to not bug the window team. Really like the brightness comparisons to Burgess A. Really helpful for the science team. Keep them coming. Thanks.
I also heard a discussion about the albedo of Grimaldi being a 10, and how many of us, when we were a little further away, saw that as the darkest albedo, and that the bigger Mare off to the west, sorry, to the east was still dark, but maybe a 7, 8. We still think that, but you are seeing color variation, albedo variation inside of Grimaldi as well, and that even on the west side, there's still a very dark part of it. But it is still the darkest. It is just not as uniform as it looked when we were farther away. We're starting to differentiate the striations of albedo inside of Grimaldi.
Copy all, Victor, and you read our mind. Superlatives like darkest, biggest are really, really helpful for us, so keep those coming.
Those words exchanged from the Orion spacecraft and NASA astronaut mission pilot Victor Glover and Dr. Kelsey Young, the lead scientist on the ground in the white flight control room, or the white figure that's in the new position for the Artemis 2 mission that did not exist on Artemis 1, given that there were no humans on board to relay science data down to the ground. And this is a new capability that is built into Artemis 2 and will continue for further missions. Just as a quick reference point, as we're looking at these views of the moon from one of the external cameras on the Orion spacecraft, if you see the larger sort of grayish piece of the moon, hang on, I'm pulling up my own lunar notes here. If you look at the right side of the moon from this current orientation, and you see the very distinctly large darker region of the moon, the very edge of that on the left-hand side of that large dark, and I'm not going to use all of the specific scientific terms that we're going to hear from the crew and from Dr. Kelsey Young. I'll try to make this a little bit more layman for everybody that is joining around the world. So the larger, darker region, the furthest left of which is the Marius Hills. If you look just beyond that and then bring your eyes down towards the bottom half of the moon there, the reference to the Grimaldi Basin, that's the little...
Houston Integrity was able to, Science Integrity was able to get a view out of window 1, which is a beautiful view. I can see the entire moon that they're looking at. We left the T-shirt up there, so I was kind of peeking through the opening in the makeshift shroud there. And once I was able to get two eyes on it, what jumped out at me was Vavilov. It's just peeking out of the Terminator. It's clear of the Terminator now, but it just really jumps out because it's still got the low light, the low sun angle. And so where the, Vavilov has that impact over the top of another crater, where the two craters intersect on the eastern edge. So on the side closest to Oriental, where the two crater rings intersect, the shadow there is the highest peak in the interior of Vavilov, and so you can see that terrain is, there's some real variation in the terrain there, that there's a nice peak where those peaks intersect, where those rings intersect, and we'll get a picture of that.
Love the description, Victor, especially the comparison and relationships you just described about topography. And if it's easier for your observations, do feel free to remove the T-shirt shroud from window 1.
Yeah, absolutely, we will do. Thank you.
Just to hop in quickly, because the communications will be coming at largely unpredictable times from Orion to the Earth. The Grimaldi Basin that you heard Victor describe, not in this past communication, but the one before that, that's the little gray shaded region that is just off of the edge of the much larger sort of charcoal gray part of the moon from this camera's perspective. And then if you keep your eyes going just to the left of that, move laterally about halfway across the moon, you can see that larger sort of ring. You can see the darker region surrounded by a couple of rings beyond that. That is the Oriental Basin, which is described by NASA as the youngest large basin on the moon, with the dark impact melt interior, which creates that different color that I was just describing, featuring the bright rings and prominent ejecta with secondary crater chains. One of the unique parts of the Artemis II mission is when they launched, they had a different science objective than the Apollo missions of yesteryear, where the Apollo crews wanted to maximize the amount of sunlight on the near side of the moon so that they could have missions of varying lengths. The goal, in part, of the Artemis II mission is to be able to make observations of the back side of the moon. You're taking a look here at the couple of different cameras bouncing around. Actually, Stephen, if we can go to the shot that is in preview right now, bring that back. This is the view from the perspective. It's a little bit, this is within the white flight control room. But if you remember, for those who were with us earlier in the broadcast, the gallery where Reed Wiseman, the commander's family, is sitting, that is almost immediately behind where this camera is positioned. So just to give you a sense of orientation of what we're looking at here in the room. You can see the screen on the right-hand side. That was the, well, if it gets brought back, that was a representation of some of the science targets for the Artemis II crew, back now on an external camera view of the Orion spacecraft. When they launched on April 1st, they were tracking a couple of different opportunities with it. Well, let me back up. Before the Artemis II mission launched, depending on when they were going to launch, that set up how much the far side of the moon would be illuminated, and therefore determine A, how much the crew would be seeing, and B, as a follow-on to that, what types of science targets they would ultimately be selecting for the crew to kind of focus their attention on. And so when the Artemis II crew ultimately did launch at 6:35 p.m. Eastern, 22:35 UTC on Wednesday, April 1st. That set up the trajectory for this mission and the opportunity to see the moon illuminated at about 20%. What you're seeing right now is a quick couple of glimpses inside the Orion spacecraft. The red light that you saw are one of the headlamps for an astronaut. Unclear who that was. As you heard from pilot Victor Glover, they have turned off all of the cabin lights in order to create the best possible lighting conditions for the astronauts as they make these critical science observations for the team on the ground. As is the case with astronauts who are on the International Space Station, the benefit of having humans in the spacecraft for the Artemis 2 mission and future missions out to the moon is that they are able to train these four individuals and allow them to act as field scientists. I mentioned that covering the Artemis 2 mission is a team sport, and it very much is, as we're focusing our attention in a couple of different directions here at Spaceflight now. I've got Adam and John, who are normally our photographers, running in a quick response research and technical support capacity, so we really appreciate them for helping out our editor, Stephen Young, and myself as we all juggle this multi-hour lunar flyby mission and make sure that we're bringing you the best and most robust possible coverage. The quick reference I wanted to go back to that Adam was able to track down, so thanks for that, Adam. Victor made a reference to the Vavilov crater, spelled V-A-V-I-L-O-V. That is to the west of a plane called Hertzsprung, located on the far side of the moon.
In science integrity, looking out of window one, I think I may have misreported earlier saying that it was Tycho going over the horizon. That was Copernicus I was referring to. Apologies. It was Copernicus is what is farthest bounding to the east, and that is now like on the horizon or just past it. And Korolev is now a few degrees from going over the horizon. And then, next it'll be Aristarchus Plateau. And so on the west, we are getting a much better view of the Terminator. It looks like we have about 80% illumination of the moon. And Vavilov and one Vavilov diameter to the west is where the Terminator is right now. And so other features are starting to peek out there. The center of the illuminated part of the moon is to the lower part is Oriental, and just around Oriental, a lot of light structure is starting to show up. A lot of high albedo, similar to the feature I cannot remember, Burgess Alpha. And Aristarchus type high albedo, in the ring. So when you look at the interior ring and the external ring, it's almost as if the edges are starting to dry up and turn white. If it was something that was wet and got dry, the edges would be the part to dry first. You just kind of outline all the topography in the interior of that wall is like it was dusted with chalk or is starting to dry, or maybe dusted with snow. If this was the earth, I would say there was snow dumped on some of the ridges on the interior of the rings of Oriental. Also, an interesting part of the discussion that I heard between Reed and Jeremy is that from Glishko to Grimaldi, there are two dark features there that look like commas, but in the wrong direction. But there's also a lot of interestingness, just a lot of geometry and squiggles and dots and lines that are starting to stand out as more small features come into view. And there also is a lot of variation in albedo. In some of those, the two dark features, for example, have on the southern edge of the larger one, the one that's further to the south, there's a very dark, the one albedo, like the southern and western part of Grimaldi, and the one to the north, closer to Glishko, is also that same dark albedo. And then around them, there are some very high albedo spots, just to the north of the southern one, and just to the west, the smaller one to the north. Very high albedo, almost approaching the 10, a 9 or a 10, like Aristarchus. And lots of little bright spots are just starting to pop up in this view. To the north, as you look up at the North Pole, there is a very distinct crater with a lot of a very defined central peak that is also 3 in albedo, and all of that area past it, going to the horizon, gets lighter and lighter, and is very, very high albedo. And I will go look and find the name of that feature if I can look that up. And then to the south, really getting some interesting geography and topography in the South Pole Aiken Basin. And the view of the South Pole is quite amazing. We've got some Terminator there, as well as the limb view, and there is a very distinct crater right at the South Pole. And I'm going to go look up, I don't believe that is Aiken, but I'm going to go look up the name of that one because it's also giving a lot of good topography due to the shadows that I'm seeing. But that's, I was trying to bound the view that I'm seeing for you, and I got distracted by all of these interesting albedo variations that are popping up in the interior. But that's the view that we see just a Vavilov diameter to the west beyond is where the Terminator is. Just beyond, I think Copernicus is the easternmost feature that we can see. A very nice ringed, very nice structure crater to the north with a great high albedo central uplift to the north, and the south is dotted by a very characteristic crater with a lot of terrain, shadow features, and I will go try to find some landmarks to put names with those. Any questions for the observation team?
Integrity Science, love the descriptions. You're definitely looking odd up there. Appreciate seeing the training being implemented. Especially interested in your descriptions of the dark patches. You compared the comma-looking features to the albedo you see in Grimaldi and notice that you're starting to see those color differences popping out. Any observations you want to make, especially when you get on, the PCD in a little bit, would really help us tease out the differences in those dark Mare deposits. Great description, Victor. Keep them coming.
Absolutely will do, and I know you've got descriptions on both of the window observers right now as well. Keep them coming.
Lots of great science descriptions coming down as you've been listening to, or we've all been listening to, NASA astronaut, pilot for the Artemis II mission, Victor Glover, communicating with Dr. Kelsey Young, the Artemis II lead scientist. The Lunar Science Lead is her official title here. Just as a way to reference where we are in the timeline of things, the Artemis II astronauts are now less than 10,000 statute miles to the moon. Again, just to be super clear for folks that might be passingly paying attention to the Artemis II mission, this is not setting up a lunar landing. That will come beginning as planned with Artemis 4 now. Will be the first lunar landing of the Artemis program. This is it's called a free return trajectory, where the crew will loop around the moon and then begin to start making their way back to Earth. Coming up at 6:44 p.m. Eastern, that is the predicted loss of communication with the Orion spacecraft, which will last about 40 minutes time as the crew goes around the back of the moon and will be in a comms blackout with the ground. Again, this is expected. Eventually, though, with future missions to the moon, the plan is to get communication relays in place in lunar orbit so that operations can happen on the lunar far side. And when you have these transits around the moon, NASA and the partners will not ever be in a communications blackout, whether it's with an Orion spacecraft, with one of the two landers for the human landing system, or one of the robotic landers that are coming from the various companies participating in what's called CLPS, which is the Commercial Lunar Payload Services Program. In fact, one of the CLPS missions that is set to fly this year comes from the company called Firefly Aerospace, based here in Texas. Blue Ghost Mission 2. Blue Ghost is the name of their lander, which, fun fact, Blue Ghost is a type of Firefly, which is why the lander got its name. Blue Ghost Mission 2 is set to fly to the far side of the moon, and the Artemis II crew is actually set to encounter one of those, or the landing spot planned for that lander.
And science, integrity, that crater to the north, that is, it's like we've got one in the north that looks like just a textbook crater, and one on the South Pole as well. The one on the north, I think, is Pythagoras. And what I wanted to highlight about that is it is either a very distinct central uplift or just a very defined area of high albedo. If a majority of the crater, especially the floor of the crater, is, say, an albedo of 5, this center, and only a tenth of the diameter of Pythagoras is an albedo of 2, maybe 3, but it is very bright and it stands out. And then between that crater and the actual what is the horizon from here, there seems to be another crater right on the horizon, and right on the edge of that is another patch of that albedo. It seems to be between the two craters. It's hard to tell from this grazing angle, but there is another spot just further north beyond Pythagoras. Between the two, I can draw a picture of this one and show you where that very high albedo, again another 2 albedo, surrounded by 5, and most of the area bounding it.
Integrity science, thanks for that. We agree with the Pythagoras assessment. And as a follow-up to your previous report, the SIR had questions about topography comparisons between the North Pole and the South Pole of the Moon, if you're willing to provide words on that.
Topography comparisons, absolutely. And if you have any idea what, if you draw a line between Pythagoras and the western edge of the outer defined ring of Oriental, it intersects a beautiful textbook crater on the south. I would love to know the name of that. The topography differences, now the South Pole has a little bit of a benefit that it has more of the terminator, and I can see a little more shadowing there, but there's a nice crater right at the South Pole, so that's the main thing defining the topography there. Seems to be quite a bit of elevation change. I can see some very jagged shadows at 90 degree just to the west of that crater at the South Pole. I can see a very distinct change in the shadow directions, indicating, I don't know, a very high wall or a very deep canyon just to the west of that. And in the north, it seems to be that from sort of the edge of the mare that's dark, which is maybe 1 Pythagoras diameter south, if you draw a ring about that, maybe the top 7 degrees of the moon, and just draw a ring around that, the near side is an albedo of 5 and looks quite smooth from here. And then along the same edge of the mare, the edge of the mare that kind of Grimaldi's just outside of, Glushko is just outside of, Carroll Crater is just outside of, and you start to see the stark differences between the darker 7/8 and the 5s and 6s, the 4s and 5s. If you follow that line up to the north, that line is also where the change in topography happens at the North Pole. The line defining the light and dark on the edge of the mare that you can see from Earth, draw that line roughly the midpoint of all that straight to the North Pole, and on the side facing the Earth you see smoother topography and dotted by Pythagoras and its next door neighbor crater. And then on the far side you see a lot more cratering and a lot more topography. And again, the far side has the benefit of a little terminator there, but I am seeing a variation in the topography. It seems to be more jagged and a more challenging place to find a place to land and to even traverse in the south, all around the South Pole. And at the North Pole, it would be more challenging to translate on the far side of the North Pole compared to the near side of the North Pole around Pythagoras.
Copy all, Victor. You really help paint a contextual picture of what you're looking at. We really appreciate the way that you're guiding us into the areas you're seeing by drawing comparisons between recognizable features. Thanks for that.
And Kelsey, another little science sit rep moment, something I just heard from the window team is the more I look at the moon, the browner and browner it looks. I thought that was an interesting observation. The 2 observers have been on timeline, no hardware issues. They did start to talk a little bit about another feature that you'll hear more about on the recordings that they call the handprint. That was at the end of their Glushko and before they moved into their current target. They thought that was worth chatting a little bit more about. And they're preparing to switch after this.
Houston copies and concurs.
Hey, Houston and Science Integrity, another just observation from the human. My eyes have shifted a little bit since I've been up here. I've been wearing my reading glasses to look at the PCD. Well, this is a very taxing event on the eyes, looking out the window and seeing the very bright moon then coming back inside to the dark cabin and trying to work cameras and microphones and logistics and lunch and those kinds of things, and then looking at the PCD, which is dimly lit. It's just been an exercise. It is a difficult thing to manage, and I'm up and down on the glasses, and then having to wait as my eyes adjust when I come back in. As soon as I look back into the cabin from looking out the window, I can feel my eyes adjusting, and I just have to work through it as they adjust.
Appreciate that report, Victor, and know that we are prepared to read you up targets from the ground if that would give you the ability to keep your eyes focused on the moon and not having to swap between that and the PCD. Just let us know.
Yeah, we appreciate that, science, and we will also do that for the window teams, and we'll back each other up that way as well. But we appreciate that. We may take you up on that. Thanks.
Communications between pilot Victor Glover and Dr. Kelsey Young, the Artemis II lunar science lead. It's just hearing from Victor there that peering out at the moon, as bright as it is, and then coming back inside where all the cabin lights inside the Orion spacecraft have been dimmed to allow for the best possible lighting conditions as they make these crucial science observations. The folks that we've been hearing on the mic, Christina Cook and Victor Glover, who are communicating with both Houston. The calls to Houston is to Jenny Gibbons, the Capcom in the White Flight Control Room. And when you hear the call for science coming from one of the astronauts on board Orion, that is communications with Kelsey Young, the Artemis II lunar science lead. Dr. Young making the offer that if the Artemis II crew so decide, instead of going back and looking at the PCDs or personal computing devices, which are the tablets that they have inside the Orion spacecraft, they can instead have the science team, in this case Dr. Young, make the call about the upcoming targets that they are focusing principally on as they continue this lunar flyby period. The clock in the upper right-hand corner of the screen, we've adjusted that instead of the mission elapsed time to being the time until the closest approach, which is just under 3.5 hours from now. I want to bring your attention to a new graphic that will be popping up as we continue through the coverage here. This is the, let's see if I can make the switch here. This is the series of principal targets that the crew are most explicitly looking at throughout the course of the lunar flyby. You can also see the relative position
and Houston, another observation, whole moon. When you look at the moon, something I've never seen in photographs before but is very apparent, all the really bright new craters. Some of them are super tiny. Most of them are pretty small. There's a couple that really stand out, obviously. And what it really looks like is like a lampshade with tiny pinprick holes and the light shining through. They are so bright compared to the rest of the moon.
We copy, Christina. Thank you. Looks like you guys might be doing it, but remind you to swap positions at the window and take your SD cards with you. We're loving everything that you're calling down, so keep it up.
the swap that was just referenced, and the reason you've only been hearing so far during this period of observation the voices of Mission Specialist Christina Cook and Pilot Victor Glover, is because Jeremy Hansen, the other mission specialist, and Reed Wiseman, the mission commander, have been glued to the window and been working in tandem to make photographic depictions of the moon, as well as calling out and giving really detailed verbal recording of what they're observing. And so the two people at the windows are most explicitly focused on that. And then you've got, in this first wave, you had Victor Glover and Christina Cook, who were able to listen in and then come back a little bit further away from those recordings and communicate down to Dr. Kelsey Young, the lead science, or the lead for lunar science, about what's happening in real time. So you've got a couple of different ways that they're collecting this science contemporaneously. The recordings that are happening with the two that are positions at windows number 2 and number 3. And then you've got folks that are making the calls down to the ground to make sure that the science team is as in the loop as possible with what the crew is seeing and understanding, the characteristics that are jumping out at them that really can be best experienced by the human eyes, which is why they've sent these 4 humans on this lunar journey in the mission designed as it is. The big graphic that you see on your screen are the various targets that they're going through, and the ones that are in blue they've gone past those as far as principal targets, and what is highlighted in green, I believe, is what is in focus currently.
Houston integrity. I wanted to provide an observation or a little bit of descriptive nature on something that we saw on the first day we had good moon views. This was when we saw more of the near side, and the ground helped me out with identifying Mare Imbrium. Mare Imbrium, when you have the western limb also in view, looks completely different than the normal view we have of the near side. It is the most striking feature of the western limb view that we had. And the mountain chains that form its eastern side are very prominent, but they actually stand out more than I'm used to seeing even on the western side, and the whole thing just feels like a big bump. It actually looks like a large healing wound with a high albedo forming the mountain chain around the impact basin. And I just don't think I had enough chance to describe how striking it was on that western limb view as we were coming in a couple days ago.
Christina, science, absolutely love that, especially since that's a feature that all of us here on Earth can observe from home. So I'm sure tonight everyone's going to be going out and looking for evidence of that beautiful topography you just said. Thanks for those words.
For a reference point, vis-a-vis the latest discussion that was just had between NASA astronaut Christina Cook and Dr. Kelsey Young, the Artemis II science lead, lunar science lead, Mare Imbrium, spelled I-M-B as in ball, R-I-U-M as in more, that is described as the largest basin on the near side of the moon, with a diameter of about 1,160 kilometers. It's about half the size of the South Pole Aitken Basin, which is on the far side of the moon.
Houston integrity, science integrity. A question and a comment. Question is it possible that we're seeing a Schrodinger basin from this vantage point in the Terminator at the South Pole? And the comment is Ohm. The rays coming out of Ohm are less distinct. We are not seeing the bright rays coming out of it, but the sort of 9 o'clock wedge that is formed by the change in albedo from the interior portion that is to the northeast to the surrounding lighter mare that's 270 degrees to the west. That 90 is very distinct and interior. You got some great descriptions from the two at the window about the colors in there, but in that darker part, in that wedge, you've got some really interesting color, even though the rays, the distinct difference in the albedo almost look like rays, but it's not the rays coming out, it's the just change in that albedo.
Integrity science, that is very intriguing, those color rays coming out of Ohm rather than sort of albedo. And as answer to your question, we do not think you can see Schrodinger. It's in darkness as of now. But thanks for that Ohm description, and it sounds like the pair at the window's got great descriptions that we're definitely going to dive into tonight.
Okay. If you could help me, I would still love to know what it is. There's a very nice crater. You're going to likely have a lot of pictures of it. What would be right in the Terminator at the South Pole or close to the South Pole where it's intersecting the Terminator right now?
Yeah, Victor, we're assuming you're talking about, kind of if you're looking at the Terminator, it's basically like 70% down from the North Pole. Is that where you're looking?
Contact, yes, that is where I'm looking.
Integrity Houston, that is an enabled caution for wastewater dump required. We have hit our limit. As expected, no crew action.
Copy, no crew action.
And Integrity Science, we're trying to figure out what you're looking at there. Is it like right on the Terminator, or is it in the eliminated portion next to the Terminator?
And Science from Integrity, excuse my space orientation adaptation. If you draw a line between Glushko through the center of Oriental, and then another line from Glushko through the southern tangent of Oriental, that line would almost perfectly intersect tangentially the crater that I'm talking about, and it is on the Terminator. So yeah, I think I'm not looking at the South Pole. I was a little twisted.
That line description was really helpful. I have eyes on the SIR right now, and they are actively discussing lunar geography. We will be back with you shortly. Integrity Science, we believe that's Zeeman Crater.
Oh, I floated away from the speaker. Say it again, please.
We believe that that is Zeeman Crater.
Zeeman. Okay, and can you say the first letter? I may be pronouncing that wrong. What's the first letter of that word?
Zulu. It's Z-E-E-M-A-N.
Copy. Thank you for that. Yes, we've got a great view of that. And when I went back to the window just now, the view has completely changed. Our trajectory is taking us to a new view, and I'm looking more into Babalov. I've got a nice, great view into Babalov. I'm actually away from the window right now, so I'm going to go try to give you some bounding words on the view that we're seeing. But I've got to get back to a window in a minute.
Understood, Victor. You're defining new views of the moon in more ways than one.
science, integrity. Wow, yeah. I wish I had some more time to just sit here and describe what I'm seeing, but the Terminator right now is just fantastic. It is the most rugged that I've seen it. From a lighting perspective, there are little islands. There are islands of terrain out there that are completely surrounded by darkness, which indicates some real variation in terrain. Up to the north, there is a very nice double crater. It looks like a snowman sitting there, in the 5-10 degrees below the pole in the Terminator. And then on the southern edge, there's almost like a hole. It looks like a hole, and it's the diameter of Vavilov size, just blackness, and then a wall of bright. And then it goes back to the black beyond the Terminator. So there's it looks like there's just a gigantic hole right there. 1 Vavilov diameter east of the Terminator. And as you go south, the Terminator is not a nice smooth arc. It's just jagged. There's almost a 110-degree turn in the shadow as opposed to the nice smooth arc, again indicating some really interesting variations. And I'm sure we'll get some photos of that. And then one of the craters further to the south of Vavilov, maybe halfway down to the South Pole, is not only it looks like just a deep hole, and then there's like 2 island rays pointing off to the west and north that indicate very high ridges and very deep canyons coming up out of that crater. So again, just some really interesting visual illusions going on with the shadows there. Like I said, there look to be islands out beyond the Terminator because some of the things, maybe even a Vavilov diameter into the Terminator are catching sunlight on the peaks up to the north and to the south. It's very, very interesting to see.
Integrity science. Oh my gosh, that was an amazing picture you just painted. I glanced over at the SIR video and I literally saw fist pumps in the air. Those types of observations are things that humans are uniquely able to contribute, and you just really brought us along with you. So thanks for that.
Boy, if you ever wonder why the 4 members of this crew were selected, you got a really good case study in that.
That's awesome, Kelsey. Did you get a SITREP updating you on a slight change in logistics for PCD use?
Christina, this is Houston. We did not, but we will take it now.
We slightly changed the PCD plan for the window observers. The 2 window observers kept their PCD. So in other words, the one that window 2 went to window 3 and the one at window 3 went to window 2 when they swapped rather than staying at the window. We'll plan on all observers keeping the same PCD for all observations.
Copy, Christina. That makes sense to us, and good plan. We are coming up here on a cabin and window team swap. Let me know when you're ready for a quick vehicle status.
Houston, go for the vehicle system update.
Howdy, Reed. We don't have much for you. We just wanted to let you know that toilet right now is no-go for use as we stick with the predetermined limit for now. All crew members, please use CCUs. Otherwise, Orion is looking very good. and you have 15 minutes in this handover time where we expect Victor and Christina to switch to the windows and you and Jeremy to be in the cabin assisting. Let us know if you have any questions.
No questions at all, and they're in the swap right now. The first thing I'll tell you, I floated up to the docking hatch window, and just what I'm going to call the Mari around Oriental just looks so different out the docking hatch right now. It's quite a bit darker. It's the same darkness, if not a little darker, than Grimaldi. But it's cool after just being in the 400 mil for the last half hour, looking up close. I got pictures of everything Ike was just describing on the Terminator. It really is a fascinating Terminator. And then Oriental just looks so dynamic right now. It's very three-dimensional out the docking hatch compared to what I was just looking at through the 400 mil.
We love it. We are getting a sneak preview from one of our SAW cameras at what you're looking at, and we see some of what you're describing. We cannot wait to see your photos. Thanks.
Yeah, Jenny, I wish you had some longer lenses on the solar array so you could see the whole moon, but man, it is, or the up-close moon, not the whole moon, but it is just fascinating here. It's so cool.
All right, MPO and Inco, take notes. We want a zoom lens on those saws next time. Thanks, Reed.
Affirmative.
Some good words there between Capcom Jenny Gibbons, one of the two backup crew members for Artemis II, exchanging words with Mission Commander Reed Weissman, giving some good descriptions of his experience for the past about hour or so as they've been, he and Mission Specialist Jeremy Hansen have been the ones behind the lens at the window, capturing all the imagery that has been described in part by Victor Glover, the mission pilot, and Christina Cook, one of the two mission specialists. Now, as you heard, they are conducting a crew swap, so where Reed and Jeremy have been going back and forth between taking images and making contemporaneous notes in an audio format so that all of the fully rich and exact science observational data is recorded as it's being observed. The now two free crew members, Reed Weissman and Jeremy Hansen, now in the spots that Victor and Christina were previously at, will now be relaying what they're overhearing to Dr. Kelsey Young, who is the science lead. She will be the other voice that is currently in the white flight control room at the Johnson Space Center, communicating with the crew on board the Orion spacecraft. If you're just joining us, we're approaching the top of the hour here. It's almost 3 p.m. Central Time, approaching 4 p.m. Eastern, 2000 UTC. If you're just joining us, welcome in. You're watching Spaceflight Now's live dedicated coverage of the lunar flyby of the Artemis II mission. As you can see in the upper right-hand corner of the screen, we are currently, I'll call it F- 3 hours, 7 minutes, 2 seconds, and counting, as the point at which the astronauts on board Orion will be at the very closest to the moon, about 4,000 statute miles above the lunar surface. And you can see in the graphical data here in the bottom right what they're looking at right now. They're just crossing 8,230 miles to the surface of the moon. For those who are just dipping into the Artemis II mission, this is not setting up for a lunar landing, nor are they, like in the Apollo 8 mission, going to be entering into the moon's orbit. The speed at which they're flying by the moon, which you can see is currently 1,031 miles per hour, will continue to pick up as the Orion spacecraft makes its approach to the moon, but then they'll be experiencing a slingshot around the moon and then begin to make their journey back to Earth. So you can see they're more than 250,720 miles from the Earth. Earlier today, they crossed an important milestone for historical record, becoming the humans that have traveled farther than anyone else in human history. One of the communications that we heard from Capcom Jenny Gibbons up to the Orion crew making their science observations as they're in this swap handover period where they will take out the SD cards currently in the cameras that were being used by Reed and Jeremy, and they'll put in the SD cards from Christina and Victor. All of the crew have been assigned specific SD cards for this mission and will do their level best to make sure that those don't get mixed up, but the serial numbers have been understood from the ground to Orion, so hopefully it all stays straight and everyone will get the proper photo credit that they are due once these photos are downlinked back to Earth. There was a reference by Jenny Gibbons about the toilet currently being no-go right now. They need to conduct a flushing operation, sending the waste material out of the Orion spacecraft, which will happen likely sometime after the formal lunar observation period ends later on tonight. In the meantime, if the Artemis 2 astronauts do need to use the facilities, if you will, they have what are called the Collapsible Contingency Urinal, or the CCU. NASA astronaut Don Pettit gave a good description, and if you're on X, I highly recommend you head over to his X account and you can see good photos of what the CCUs are like. He describes them as, quote, an open container, reusable, sealable, and drainable, that controls the urine-air interface using capillary forces like my Space Cup does for coffee. Don Pettit created and patented a really unique design for coffee cups that astronauts on board the International Space Station have been using for years now at this point, allowing them to enjoy a fresh cup of joe. You just don't want to get those two mixed up, of course. But the CCU is considerably longer than the coffee cup, so that hopefully won't be an issue. As he says in his post, and I'll quote him here and give him the comedy credit he deserves, quote, when you're in cislunar space with a broken toilet, you need contingencies.
Houston, the professional science update giver is now in seat 2. That is where Victor is, and Christina is nestling into seat 1 with the long lens, and we're just getting ourselves oriented here. It's a cool view in the cabin. It's actually a cool view to be off the camera now and looking at my crewmates getting up to their observation post and looking in. It's super fun.
Copy, I'll read. We like it.
Just to quickly close the loop on the comment from Don Pettit. When you're in cislunar space with a broken toilet, you need contingencies, and the CCU replaces the need for about 25 pounds of diapers, end quote. Don Pettit, good behind the camera, and quite a witty astronaut as well. Currently now 3 p.m. here Central Time, 4 p.m. Eastern, 2000 UTC, as we're currently looking at about 3 hours, 1 minute, and just under 30 seconds remaining till the closest approach of the Orion spacecraft closest approach to the moon by the Orion spacecraft that the crew named Integrity. As you can see with the telemetry data in the bottom right-hand corner of the screen, we are approaching 8,000 statute miles between the surface of the moon and the Orion spacecraft. The closest that they will come is about 4,000 statute miles.
And Jenny, for the science team, if they can mark this time, I just covered up window 4 to block out the ambient light from a very bright planet Earth. And it'll be interesting to see if in the data, Victor and Christina see any differences from me and Jeremy with that window blocked. It's a lot darker in the cabin now.
Copy, Reed. We're taking note, and we'd be curious too.
Integrity Science for a science sit rep when you're ready.
Houston Integrity, we have no external view of the moon right now for the floating crew members, so my only science sit rep is that we have Victor in window 3 doing observations and Christina in window 2 with the long lens.
Integrity, we copy. Are the shrouds still on windows 1 and 4? And if so, would you consider trying to get a view through one of those windows?
We cannot take the shroud off of 4 because the Earth is too bright and it's impacting Ike's peripheral vision. And then I can get a grazing glimpse out the docking hatch window. I can see Oriental south down to the South Pole. And the primary thing that I see from Oriental right now is just the long trenches that come out. And, you know, when you come out the north side of Oriental, the ejecta kind of boulders across the northern half of the far side. But coming out the southern half of Oriental, I just see those large, here they look like gorges or almost like rain when it comes down the Grand Canyon and fingers off into the desert is kind of what it looks like. Also, Burgess Alpha is extremely bright. It's the brightest thing that I can see. Even brighter now than Aristarchus, which is heading off to the Terminator. It's almost impossible now to see Aristarchus, the thing that Jeremy and I looked so much at. I can just barely see the crater rays from Ohm, and I would say for albedo right now, I would go back to Grimati is still extremely dark, especially in that southwest corner, and there are parts of Oriental and the outer ring of Oriental that reach that same level of darkness, especially the rings of Oriental reach the same level of darkness as Grimati. And then south of Grimati, Jeremy and I were noting a few other just really dark areas of cratering, Mare there, and those have that same darker albedo, but Burgess Alpha is the brightest, and Grimati is the darkest.
Integrity Science, that was a great description. Thank you, and thanks for the docking window geometry to give us that description. Any comments before you go on the annular ring in Oriental?
The annular ring, which I think everybody kind of describes as like a pair of lips or a kiss on the far side of the moon from here, is very circular in nature. The northern part of it is wider, darker. The southern part is much lighter. It is very neat looking, and but it is far more circular than I remember it looking in our training. The darkness of the northern side of the annular ring is the same darkness from here out this docking hatch window as the center mare in Oriental. Not quite as dark as Gravati, but it is probably only because dust and lunar regolith has kind of impacted over time.
Reed, that's exactly what we were looking for. Thanks so much. You have heart hands coming out of the SIR.
Say that again, Kelsey.
Just saying that the SIR was really excited about that. That annular ring was something we were really eager to hear about, so thanks.
Yep, you bet. And now Victor and Christina are moving on to Oriental. I got them situated over there a little bit late.
You've been listening to communications between Artemis II Commander Reed Weissman on the Orion spacecraft and the woman that you're seeing there stand in the box in the upper left-hand corner of your screen with the dark jacket. That is Dr. Kelsey Young, the Artemis II lunar science lead. The reference to the SIR, as we just heard, that is an acronym, stands for the Science Evaluation Room. As the observations from the crew members of Artemis II are coming down verbally, they're being evaluated, and the team and the SIR are also making their own observations based on what is seen and what has been predicted will be seen as the trajectory brings the Artemis II crew continuously to begin their flyby around the moon. Currently, as you can see in the bottom right-hand corner of your screen, the astronauts are about a little more than 7,400 statute miles above the moon's surface, traveling at a velocity of a little more than 1,000 miles per hour. The clock in the upper right-hand corner of the screen will continue to tick down as they are making their closest approach to the moon, which will be roughly 4,000 statute miles above the lunar surface. This graphic in the big part of the screen has a ticking list on the far left-hand side. The items in